and I'll have to wait to see the average, but you know, the average score hasn't been that great for the exam. So if you didn't do too well on the exam, you're not alone, and I have to figure out why that is and what went wrong, because I've given the same exam in previous semesters and it's gone fine, and I don't know what I messed up this time around as far as teaching or preparing you for the exam. So because there were a lot of issues with a lot of the answers. If, however, you manage to score in the single digits, which a couple students did, that's really not good. But as far as the score, again, the overall scores, I don't know. I should hopefully have them all done and graded tonight, but I will be working on trying to make sure that you get your scores, and I'm going to see if there's like a comparison between students who have been doing well, you know, and coming to class versus not. But I suspect basically the average is probably going to be somewhere in the mid 60s. That is what I suspect. Which then begs the question of how do I curve these things? Because I don't curve exams. It's just not the way my class works, because trying to figure out a statistical average for an exam is not that great or not that fun, or basically does not necessarily help people who do well versus people, you know, or people who do it well equally. What I do is at the end of the semester, I do assign a curve. I never adjust the raw scores of what you learn in class. What I do is I stretch the range of all of what the scores are going to be. So for the past couple semesters, getting an 88, 89, or an 89 in this class was enough to get you an A-, whereas 90 and above were an A. So although last semester was a real, I don't know, semester was so weird. I gave out students earned more A's than I'd ever seen before, to the point where I'm surprised that neither of the chairs have reached out and said, "Are you just giving students all A's?" Because I wasn't. So that said, the second exam generally goes a whole lot better. A whole lot better. But I need to figure out what went wrong. A lot of students did mess up the question with regards to what is your what is the runtime of your code, which should have been almost certainly that was covered in your homework. So like I said, I don't know what measures I'm going to take. However, I don't know if the scores are lower also because I don't know if I've been grading harder than I had last semester. That's also a possibility, right? That said, if you feel there is a mistake with your score, it is completely possible that I just completely misread your code, or that maybe you deserve more points than you should. My philosophy on grading has always been to grade harder, because it's always easier for me to give points back than take points away after the fact. Because, you know, taking points away after the fact, that's just like a jerk move. But if you feel like there is an injustice in your grade, please let me know. I will be happy to sit down and look at that with you, or meet over spring break or something, or afterwards to just kind of discuss. But again, I'm still working on grading all the exams. And if I have to figure out something to like rectify, you know, to give you the chance to rectify these mistakes, then we'll see. Okay, because the point of an exam is to evaluate what you know. And if I have a consistently low score across classes, that either means it's a poorly designed exam, which possibly, or I didn't teach what you needed to know, which is also a possibility. So that's why I have to figure out what's going on here. Yes.
Can you post the answers to the sort
I can go over them. I feel not, I don't want to post them yet because I still have like 1 or 2 students with coronavirus who or had COVID issues who needed to take the exam. But I would be happy to go over them at some point in the future or privately. But I'm not going to just simply say figure it out. If you did well on, if you know somebody who did, if you did well on it though, so long as the other person has taken the exam, feel free to share your answers with other students in the exam, so long as they've taken that. That also lets me know if I was inconsistent with my grading, which is also a possibility when you've got a 5-year-old distracting you, trying to distract you at various times. So, so point being is that we'll see what the average is, because I don't like having a bad average in my class, because that I feel it's not just a reflection of you, but also a reflection of me as well. I have to again check what it is with the previous semesters, but we'll see. Now let's talk about today's what we're going to do today, because it's different than the way most classes work today. Today we're actually going to do an in-class exercise. It's one of my favorite exercises. You may have seen the video about it already, but if you haven't, let's have fun again about this. Because we might as well leave off on spring break on a fun note, okay, which is the Towers of Hanoi. Now, again, part of the reason I really like teaching this class is because we deal with puzzles a lot, like a lot. I really like puzzles. I'm going to open this up in here, but actually I'm going to open up code, a VS Code, so that I can just type out some pseudo code at first. Now, what in the world is Towers of Hanoi, in case you haven't? So Towers of Hanoi, also known as Towers of Brahma, is this fun game I really like. And again, this is one of those places where Wikipedia just proves itself to be an invaluable resource, because not only does it talk about like what it is, but it talks about ways to solve it, right? And which you just don't get with like standard encyclopedias. And you got nice, beautiful animations to go along with it. This one is a gigantic Towers of Hanoi at Mexico's University Universum Museum. This is a huge one. Now, and that probably is not necessarily solvable in a reasonable amount of time, because the amount of time it takes to solve, the amount of moves you have to make to solve a Towers of Hanoi puzzle is as follows. Give me 1 second. It takes 2 to the n minus 1 moves to do to solve a Towers of Hanoi puzzle, where n is the number of disks. So again, if you're looking at like 16 disks, that's a lot, right? That's a lot. That's a lot. I mean, for instance, I know that 32-bit disks would give you 4 billion. I don't know necessarily what 16 is off the top of my head, 2/16, but that's a lot of moves. Oh, right, it was right there in the description, article description. Yay. But it also means that 3 disks is a 7-move puzzle. Now, how does the way now normally I have a small set with me, but I don't want to lose, but it's tiny and I don't want to lose the pieces. But the rules for Towers of Hanoi or the game, the objective is that I want to take all these disks and move them into this one. And you're like, okay, that's not too hard to just pick them up and move them onto the last peg, So obviously there are some rules to that objective. And the rules are as follows, that first off, you can only move 1 disk at a time, which still isn't that bad, because I'll just, if we consider these pegs to be stacks, I'll just hop off the top of each of this guy over here, move them and push them onto this one. So now it's in reverse, right? And then pop that, empty that stack by popping each item off once at a time and pushing it onto this peg. So kind of just like, tumbling it over, tumble it on and then like that. So not really a tough puzzle, right? Well, that's why we have one more rule, which really makes it a dreadful puzzle, which is no disk may be placed on a disk that is smaller than it. Right? So here, right, is a Tarzan. So here, right, I can't do this. Just won't let me. I can, however, do this. Right? I can move any piece on top of an I can move any piece on top of another piece so long as it's smaller than that piece. So and as you can see, it's not necessarily too bad to do once you know the process. It's knowing the process that's tough. Right? The process is that we really just want to, is that this is a recursive puzzle. Okay, this is a recursive puzzle. And that seems silly, but what this is that basically, if I want to move 3 disks over to here, I want to move these 3 disks over to here, right? In order to do that, what I have to do is because I can move only 2 disks at a time, what I have to do is that I have to move these 2 disks out of the way, right? I have to move them over here somehow, which I'll do right now, right? I have to get these 2 disks out of the way so I can move the bottom one over. So to move 3 over, I have to take to move over n disks to the last peg, I have to take n minus 2 disks and move them over out of the way, and then take those n minus 2 disks and move them onto the last peg, right? So how do I move n minus 2 disks? So basically 3 says I want to take, to move 3 here, I want to move 2 guys here, which means I want to move 1 guy here. Is kind of the way it recurses, right? To move 3 disks over to the end, to move n disks here, I want to move n minus 1 disks over to here, and I want to move n minus 2 disks over to here, and so on and so forth. And fortunately, again, Wikipedia comes to our rescue with a wonderful looking kind of flow chart for a recursive solution. Okay, normally this, oh, right, okay. So here we go. It's because I was zoomed in like crazy. So basically what it's saying is, hey, you want to move 4 disks over to here. What we do is that we split this problem up into moving 3 disks out of the way, then moving last disk over, then moving those 3 disks back on. Now that problem, moving 3 disks out of the way, that is further split up by moving 2 disks out of the way of that. So you can move the bottom disk of that pile on and move the 2 disks back on. And that is just simply reduced down to move this out of the way, move disk 1 out of the way, so you can move the bottom of the pile 2 and move that back on. And it just kind of expands like that. So the recursive, so let me go ahead and solve an actually non-trivial puzzle really quickly, which is 5. All right. So for 5, we want to move this 5 over to here, right? So in order to do that, what I have to do is I have to move 4 disks out of the way over here. To do that, I have to move 3 disks out of the way over here, which means 2 disks over here, which means 1 disk over here. So what we're going to do, so now I've got 2 out of the way, so I can make a pile of 3 over there. We've got a pile of 3 over there. Now I need to make a pile of 4 over here in the middle so I can move these guys over. So to move a pile of 3 over here, that means I have to move a pile of 2 over here. It means put 1 here. So now to move a pile of 2 over here, I have to move this out of the way, put this on and this on. And now we can move our bottom on like that. So now to move a pile of 4 over onto the last peg, I have to move a pile of 3 onto the empty peg, which means move a pile of 2 onto the end peg, which means move 1 over here. Okay, so now I can move this out of the way, which means I can move this here. And so now I want to move a pile of 2 over to here because this needs to be empty so I can put the 4 on. So move these 2 over to here, which means move 1 over here. It helps if you talk through it and you know when you know the algorithm. Now to move a pile of 3 over here, I got to put 2 here and put 1 here. So 2, boom, and now that's clear. Now I got to move those 2 over here. That means move this over here. And as you can see, I did a minimum number of moves. So the pseudocode is as follows. Okay. So this is the pseudocode for this, okay? Towers. Let me go ahead and up the font size. Preferences setting. Really? Okay, 36, I guess. Towers. We're gonna take in, we want to move let's call this move. Move n disks from start from the let's call it, yeah, the origin to the so first off, what I have to do is I'll need 3 kind of pegs over here, like A is equal to, A is equal to 1, 2, 3, B is equal to, and these are going to be basically stacks, okay? And the reason I need them over here so that I can refer to them in order, because which is my origin and which is my target, and which is my storage, those are the order of that's always going to vary, right? The order of that's always going to vary. So if I want to print out the progress of this, I need to do something like this. I need this because I want to be able to print out these things. So print A, B, print, let's see, print A, print B, print C, okay? So the actual program looks something like this. If n is greater than or equal to 1, then we have disks to move, okay? And let's go ahead and indent over here. So if n is greater than or equal to 1, then what I want to do is what I have to do to move n disks over from the start to the finish, the origin to the target, I'm going to move n minus 1 disks from the origin to the target, not to the target, but to the storage, and use the target as kind of a backup area to do that. Okay. Move from origin to storage using the target as kind of a backup area to move the other disks to. And then once we've moved everything from, then we need to take, let's see. Then what do we need to do? We want to take origin.pop target.push, right? So we move the n minus 1 disks out of the way, right? We take the n minus 1 disks, move them out of the way. And then we put the last remaining disk into its target location. Okay. And then what we need to do is that we need to move those n-1 from wherever they are, which is the storage. We got to move them on top of the target using the origin. Well, the origin goes here because it's got to go by there. Yeah, that's it. That's really it. And you're going like, Professor Rosen, this looks all good and has nice pseudocode, but this is in no way, shape, or form a program. It's just pseudocode. And to you, I say, yes, that is correct. It's just pseudocode. So let me go ahead and put this here, this here, this here, and yeah, it's identified it as a Python program now. And now all I have to do is just do that because there is no, there's append all your lists and stuff. And so now I can, yes, I know this is a Java class. You're going to do this in Java now. Really? It already exists. Okay, fun. So now we run it and I got to call it move 3 disks from A to C using B, and B is the third peg. And what we're going to do also is that I'm going to go ahead and print a like a, that. And don't worry if you don't know Python. It looks like pseudocode anyway. And there you have it. Move. Let's see. Aha. So the issue is that I've got the smallest disk. I've got the biggest disk on top. So let me go ahead and fix that now. And now it should work exactly as I intended. Okay, so now, right, we move 1 over to here, then we move the 2 over, and then we put the 1 on top of the 2. And then we move the 3 over into the third peg, right? And so on and so forth. So your exercise for the day is to translate this into Java. Create a Towers of Hanoi solution in Java. The pseudocode for this, by the way, can be found. I believe it still can be found in here. Let's see. Recursive solution, recursive implementation. Yes, it can still be found here on the Wikipedia page. Amazing how similar that looks to mine. But I want you to implement a recursive solution for this in Java as opposed to in Python. And I want you to upload your solution, your Java file, to the Towers of Hanoi, so to the Towers in class, which is worth 10 points. Okay. Honestly, that should go under the quiz grades as opposed to anything else. So yeah. But yeah, your Towers in class exercise. And just simply either upload your code or just paste it into a text box. That's what I want you to do today. A bit of a change of pace, right? Just small in class exercise. All right. So you can go ahead and work in that. If you have questions about the exam as well, you can come and ask me.